Hello students, this is lesson U2A01. In this video, what I'm going to do is derive the quadratic formula. So in the last video, we went over some of the history behind what the quadratic equation was. And in that video, we went over this inheritance question. And this inheritance question was very, very specific, right? What we're going to try and do is we're going to come up with a formula that we can isolate x with, okay? Rather than having to go through the process of completing the square over and over and over again, where we are just going to apply the process of completing the square once, and then it will be universally applicable, okay? So what we're going to do is we're going to bring over the 39 to the other side, so we have something like this. And what we end up with is, this is the quadratic equation written in standard form. And just to be super general, we can write it in this manner. ax squared plus 10x plus c. So where, again, a, b, and c, whoops, that should be a 10, that should be a b. Where a, b, and c are going to be the coefficients of the quadratic equation. Okay, and so what we're going to try and do, okay, is we're going to come up with the quadratic formula by isolating x here. So how's that going to work? Well, what I'm going to do, okay, is I'm going to bring back the constant over to the other side, okay, having now the understanding of what it means to write something in standard form. I'm going to bring that to the other side. I'm going to have ax squared plus bx is equal to negative c. And what I want to do with this, okay, is I want to divide out the coefficient here, a, okay, so that I end up with a very similar problem like I did in that example there. Okay, so what we're going to do is we're going to divide a into every term on both sides of the equation. So if I divide both sides by a, I'll end up with something that looks like this. I'll have x squared plus b over a times x is equal to negative c over a. All right, so with that now, what we're going to try and do is we are going to try and complete the square. If you don't remember what completing the square is, okay, we actually went over this towards the end of geometry, right, where we had to complete the square to find the equation, to find the center and radius of the of a circle graphed on a coordinate grid, on a coordinate axes, right? This was also a topic that was covered in when you guys took algebra. So what we do, okay, or the technique is, we take the middle coefficient, and what we do to it is we're going to take that middle coefficient and we're going to half it. So 1/2 of b over a is simply b over 2a, and then we're going to square it. By doing this, okay, the left-hand side will now become a perfect square. The right-hand side, okay, will also, what we do on the left-hand side, we got to also do on the right-hand side. So this is what we end up with. We have x squared plus b over a times x plus b over 2a squared is equal to negative c over a plus b over 2a quantity squared. This expression on the left, okay, is in fact a perfect square. And if you recall, when we did factoring and when we did multiplication of polynomials in the previous unit, this is actually a perfect square now, and it can be re-expressed as x plus b over 2a quantity squared. The right-hand side, I didn't do anything to it yet, okay, so it gets rewritten to look like this. Now what we're going to do is we are going to try to isolate x. So to isolate x, we're going to undo the square. So to undo the square, I'll end up with x plus b over 2a is equal to the square root, but it's going to be plus or minus, because whenever we take the square root, okay, of both sides of the equation, we end up with both a positive and a negative value. We end up with this. Okay, and what we're going to do next is we're going to isolate x by subtracting over b over 2a. So if we do that, we end up with x is equal to negative b over 2a, and then we have that plus or minus square root piece. So actually, this is the quadratic formula. Okay. However, it is refined a little bit, so we're going to do the same thing. We're going to do a little bit of manipulation, okay, to manipulate that last step. So if you look at the last step there, okay, we really have two terms here. We have negative b over 2a plus or minus that giant square root. So what we're going to do, okay, is we are going to take this square root, and we're going to manipulate it a little bit by creating a common denominator that's inside of the square root there. So how will that look? So what we're going to end up with is x is equal to negative b over 2a plus or minus, we have a giant square root. In order for me to create a common denominator, I need to get that b over 2a squared. I need to actually get that out of the parentheses. So that's negative c over a plus I have b squared over 4a squared. And then from here, it's a little clearer as to how I'm going to create common denominators. I need to multiply negative c over a by 4a. So if I do that, okay, I'll end up with x is equal to instead of writing negative c over a, I'm going to multiply this guy by 4a, so I get negative 4a c all over 4a squared. And we can actually combine this all into one giant fraction. So the next step would be this. And the denominator here, we can combine them all into one denominator. So I end up with something that looks like this. And last I checked, 4a squared, isn't that a perfect square? It most certainly is, isn't it? Right? So what I end up with as a result is something that looks like this. The square root of 4a squared is going to be 2a. So the denominator here becomes 2a. And because I am adding and subtracting two things with the same denominator, I can just bring it all together, and the formula is exactly like what we're familiar with. And I'm just going to rearrange the square root inside so to make it b squared minus 4ac, and then all over 2a. So there you go. This is the quadratic formula.